Perfect. All right. So 2024 IECC, this code has been in development for considerably longer than they would typically take to develop the code, and that's simply because they have changed their process for code development, right? So there's a lot more public commenting that ended up happening in the development process. So usually we would have seen this probably July of 2023, but we honestly didn't see the code until in its final stages anyways, until really the end of 2024. So feels like we're definitely a little bit behind. That said, it feels like, just, a couple of months ago, I was still talking and basically going over the 2021 requirements. So time does fly pretty quick. So with this code, there's not a ton that has changed. So I'm going to try to keep it fairly short. I only have, I think, maybe like 15 or so slides that I'm going to go through. So hopefully that will be a relief for most of you. And maybe about 80% of you will still be awake by the time we're done here. But um, we'll see. So here are the items I was going to go through. So there are some changes to the new occupancy sensors, new occupancy sensor requirements, sorry. There's some new dimming requirements. It's a brand new section, new daylight zone requirements. This one's interesting because although this probably has the fewest adjustments to characters written in that code, it has quite a big impact overall on the design process. So I'm going to probably focus a little bit and kind of do a refresher on calculating daylight zones. We have a lot of people on this meeting. A lot of you guys, I'm sure, probably have done this a gazillion times, but I'm sure we have some people that are newer that maybe haven't done it as much. So I wanted to kind of go through that and take that opportunity and kind of highlight, the impact of that daylight requirement change. So another new section, demand response controls. I have this marked as optional, and I'll kind of explain why. And then I have some noteworthy things regarding code, the new code, as well as 21 that I kind of want to touch base on, and then we'll do our Q&A at the end. All right, so jumping right in, new occupancy sensor requirements. So this one hasn't changed a whole lot, right? There's not any new functionality really that is required for this section. They simply took the existing list of spaces that require occupancy sensor controls, and they have basically, added some more spaces to kind of go with the latest trends. So I've got those spaces highlighted here. So these are the ones that were added to spaces requiring occupancy sensor controls now. So one of them that I kind of found interesting, data centers, that makes sense, right? Because we've seen a huge uptick in the amount of data centers being developed with all the new AI developments happening. So that makes sense because data centers really didn't fall under any of the previous categories. So technically, they would have probably fallen under the schedule-based requirements of the code, which doesn't really make sense for a space like that because it's more of a 24/7 type of facility. So you have people in there kind of at all sorts of hours. So trying to schedule your lights didn't make sense if you're trying to conserve energy, right? Another one that I found kind of interesting and kind of made me reflect a little bit, right? Because the telemedicine room and healthcare facilities. So if you really think about that, that's kind of probably driven a lot by COVID, right? Because a lot of doctors started seeing their patients remotely. So I think there was a lot more of these kind of space types that ended up going into your medical facilities. Whereas before, maybe they didn't really understand whether that space needed to classify under exam room or does it need to classify under office space, which would require occupancy sensor controls. So I think they just decided to go ahead and add that in under the occupancy requirements. I've got the corridor requirement highlighted over here. And really that's more so just to kind of point out that this was the latest change in the 2020-21 IECC that did have a fairly big impact. I put the exceptions section in here. I wanted to kind of cover that to make sure that it was clear what it was stating. So all the spaces that you see on this list here, they're technically required to have vacancy mode or manual on control requirements. In other words, you walk into that room, yeah, it has an occupancy sensor, and that occupancy sensor might sense that you're there, but it's not going to automatically turn the lights on until you hit a switch on the wall. So most of these would have to have, low voltage controls of some form or another, unless you can get away with a wall box sensor in the space, then you can keep it line voltage. But if you have ceiling sensors, technically you're going to end up with a low voltage switch on the wall. So what the exception here is saying is full automatic on is permitted for these space types: corridors, interior areas, stairways, restrooms, locker rooms, library stacks, and anywhere having to push a switch on the wall to get your lights on could endanger the occupants, and whether that's safety or security. So just wanted to clarify that portion of it. Other than that, again, functionality really has not changed. You still have your 20 minutes timeout requirement. That has not been reduced any further just yet anyways. So they just basically added these few more spaces. So next one on the list is the new dimming requirements. So this is brand new to the code. So 2021 IECC, you're not going to find a section that tells you you have to have dimming in such and such spaces. Back in 2021, I think they call it light reduction controls, and that basically just gave you um, uh, this details on how dimming needed to work if you are using dimming, but it didn't really tell you where you needed to do it. The only other space or place in the code that it was referenced was in your schedule-based controls. Basically, what they were saying is if you're not going with occupancy or vacancy sensors in your spaces to meet the code, and you're going with schedule-based controls through a time clock or something along those lines, then you would have to have light reduction controls in that space, right? So 2024 has now stated all of these spaces on this list at a minimum would require manual dimming controls. Maybe not a huge impact to you guys because a good portion of you have already been putting dimming controls in these spaces kind of as more of a good practice, right? Because you probably want to have the end users have the ability to reduce their lighting in these kind of spaces, classrooms, offices specifically. LED lights are bright, so people are going to be unhappy if they have no way of trying to dim them down and avoid headaches and etc. So, but now you don't have the ability to VE a project down to bare bones and make it switching only in these spaces, right? Because that was probably one of the biggest things that I've seen getting beat out of projects is the dimming capability in a space. Because technically a classroom even didn't have the requirements of needing to have dimming per code. You could make it vacancy mode configuration, and you would be meeting code and that would be fine, right? So that is no longer the case. This very last item over here, just to kind of clarify this, it reads a little funny. It almost seemed like there was a comma that needed to be in there or something because it took me a while to read through this and really understand what it was saying. But basically, they're saying that spaces that do not need to comply with occupancy sensor requirements, meaning that they're not on this list over here, they need to have manual daylight reduction controls. Okay. Let's look at some of the changes to the exceptions inside of the dimming requirements. So for the light reduction controls, they used to have, these items 1 through 4 here listed out as an acceptable exception for not having to do manual dimming. So one of those was if you had a daylight zone, you didn't have to have a manual dimmer controlling that daylight zone. The photocell can do its own thing, right? So that got removed. They removed the exception for spaces with a single luminaire that was under 60 watts. You didn't have to do manual dimming for that kind of space. They removed the exception for spaces that were under 0.45 watts per square foot. And this one's kind of interesting. They removed the exception for corridors, lobbies, and electrical rooms to not have manual dimming. Now, if you go back to this list, the only one of those 4 that are on there is lobbies, right? So corridors are not on the list of spaces that technically would require manual dimming controls. Corridors do require occupancy sensor controls, however. Electrical and mechanical rooms, they don't require occupancy sensors, and they're not on the list of spaces that are mandatory to have dimming. However, you could probably argue they might fall under, item number 11 here, spaces not required to comply with occupancy sensor controls. Now you might potentially have to have dimmer switches in those spaces. And that's my interpretation of the code. If you guys read through it and see it differently, please feel free to reach out to me so we can discuss, because I'd like to get that one figured out. I've always promoted not putting any sort of control, especially automatic controls in electrical rooms. I think, or mechanical rooms, really. I think there's a section in the NEC that states that, these spaces are not to have any sort of automatic off controls for safety reasons. Having them be able to dim, probably not as big of a deal. So if they do now need to dim by code, that's probably fine. One thing to keep in mind though, if you do put dimming capability into these spaces, try to do, a single switch at one location. Some of these might have multiple entry points to the space. Try to avoid doing three-way dimming. That's going to drive your cost up. Technically, if you put a dimmer at one end, a line voltage switch at the other, they still have the ability to reduce their lighting. They're still meeting the code requirement. And that would be the most cost-efficient way to treat those spaces and still meet the code. So they did add an exception for luminaires controlled by special application controls. So mostly that's talking about your task lighting, supplemental task lighting, any sort of accent lighting or lighting that's being used for specific for like sales demonstration, right? Those do not have to manually dim. If they are sharing a space with general lighting, so if you have a sales area or something like that, you have your general, choppers or something on the ceiling, but then you have maybe some track lights that you're using for display, just make sure your track lights are individually controlled from your general lights, your choppers, which those may still need to be dimmed, right? And then another bigger exception here is they allowed you to, and this exception actually falls under the dimming functionality where they describe how the dimmers need to work. But essentially, if you don't want to do manual dimming of a space, you could use controls that allow you to set a high-end trim setting on it, right? Just keep in mind that the end user should not have access to those adjustments for the high-end trim. So once it's set, it's only able to be changed by authorized personnel. And if you do give the end user the ability to adjust that lighting, that they don't have a way to override that high-end trim setting. So some things to keep in mind as you're designing projects is you can still meet all of these code requirements, the occupancy sensor and manual dimming requirements in spaces with simple analog devices that are pretty cost efficient, right? So as long as you don't have something like through-way dimming going on, or you don't have daylight harvesting going on, where now your manual dimmer is going to have to fight with another manual dimmer or a daylight photocell, you can usually get away with just doing analog controls, and that will, be the most cost efficient way of getting that done. However, analog basic controls don't have a way usually to set any sort of trim setting. So if you're trying to use this exception to kind of avoid, you know, costly dimmers or whatever, just keep in mind that typically you're going to end up with a digital system where those settings are going to have to be programmed. So, all right, moving on to the next one. New daylight control requirements. So again, the verbiage in this section didn't change, but by, a few characters in the code. However, the impact is pretty significant, right? So what they ended up doing is essentially halving the wattage requirements that would push you into having to do automatic daylight harvesting within your calculated daylight zones, right? So it used to be 150 watts for your primary daylight zone that you could get away with as long as you were at or under that 150 watts. You didn't have to do automatic daylight harvesting. So now that requirement drops down to 75 watts. And that's pretty crazy. I mean, that's almost a 60-watt light bulb at this point. So that's a pretty significant change. Being that we have primary, secondary daylight zones, again, there was a requirement that you can, get by with less than 300 watts between the two and not have to do daylight harvesting. That has also been cut in half, so 150 watts. And same for your top lit daylight zones, your skylights, clerestory spaces. Those have been reduced to 75 watts. And then they also removed the exception for being able to use this formula right here, which honestly, I'm looking at this thing and it kind of reminds me of, back in college and civil engineering classes. I don't know if that I've ever seen anyone use this formula as an exception. to not have to do daylight harvesting for a space. But you're not going to be able to use it going forward. Um, I did want to point out that I'm really grateful for all of you guys who do show your daylight zones on your plans. And a lot of you have been using the exception for the wattage. You'll note that, hey, here's my daylight zone, right? But there's less than 150 watts of fixtures in this space, daylighting not required. That really, really helps us, especially during the bid processes because a lot of times, and I'll kind of show you here in the next sections, in order for us to calculate those daylight zones, we have to have information that we typically don't get on bid day. And again, bids turn pretty quickly. So when you guys do put that information on there, make it really clear for us. It makes our lives way easier, and we can guarantee that whatever we're putting out as a lighting control package is going to be code compliant. So really appreciate it. There was an exception added for private offices that are less than 250 square feet in total space. You don't have to have automatic daylight harvesting in there. So if you somehow manage to design an office that's 250 square feet, that's going to have over 75 watts of light in there, congratulations, but you're still safe. You don't have to do any sort of automatic daylight harvesting for that space. So let's look at calculating your daylight zones, right? How do we figure out where we need them? How are they calculated? What does that look like today? So let's just say you had a window. The window needs to be at least 24 square feet or larger. Otherwise, you don't have to do or add that window into your daylight zone calculations, right? Next step that you want to do is take the window height. So from the top of the window down to the floor, that's your first measurement. That gives you the height value. Then you're going to look and see how wide does my daylight zone need to be. So the daylight zone is not the width of the window. It's actually the width of the window plus h, technically. It's half h to the right, half h to the left. So that then gives you your daylight area, your daylight zone area, I should say. So if we look at this at a section view, then all you're really doing is you're dropping that same area down onto your floor. And that then you're basically looking at your reflected ceiling plan and seeing what that looks like, right? So here's my primary daylight zone. Then I need to add in my secondary daylight zones. That's fairly easy because all you're doing is doubling up your primary. You're going in another daylight zone into the space. And now the next step is looking at your fixtures, right? So you see which fixtures are in that daylight zone or in each one of these daylight zones. And you're seeing, okay, in this case, primary daylight zone now only gets 75 watts, secondary gets 75 watts, or collectively they can't exceed 150 watts. And you're seeing if you're going to have daylight harvesting in that space. So again, I think this is going to have a pretty big impact because in theory now you're basically doubling, if not more, the amount of spaces that might require to follow, the daylight requirements on a project. Looking at skylights, so the way that these would be calculated, in this case, we're using ceiling height and not the skylight height. So a lot of times skylights are, they recess up into the ceiling. They're not necessarily flush with the ceiling. So you're not measuring all the way up to the skylights. You're just measuring the ceiling height in the space. And then you're taking 75%, or sorry, not 75, 70% of that to each side of your skylight. So if your ceiling height was 10 feet, you're going 7 feet to the side of the skylight, and then this gives you your daylight zone. So any fixtures that would fall into this zone, again, if they exceed a total of 75 watts, then you would have to have a daylight sensor controlling those spaces. One thing I did forget to point out here with the window zones, right? So let's go back real quick. When you're doing this calculation here from the side to side, let's just say that height was 8 feet tall, right? So if you had a window to the right that was within 8 feet or to the left within 8 feet of this main window, now you're looking at both windows combined when you're trying to figure out the width of your daylight zone, right? because they're within that side calculation limit of one another. So basically, it gets harder and harder to get away, especially in open office spaces. It gets harder and harder to get by with getting away with daylight zones. All right. So moving on to clear story, very similar to skylights. So a clear story, we're looking at the height being calculated from the very bottom of the window in the clear story down to the floor. So unlike your side-lit daylight zones where you're calculating from the top of the window down, with clear story windows, you're calculating from the bottom of the window down. So your height is calculated based on this distance right here, right? And then your width of your daylight zone is going to be calculated at basically half of what the side-lit zones require. So instead of doing half of your height measurements, you're doing a quarter to each side. So that's how you're going to get your width and how far that daylight zone needs to go into this space. And same story here. We are looking at the fixtures. If it's under 75 watts, we're good. If it's over, we're going to have to do automatic daylight harvesting for those zones. So again, I feel like this is going to have a pretty big impact on projects. All right, so moving into the next section, provisions for demand response controls. So this is brand new to the code. That was never in there before. And this is kind of interesting because the first time I read it, I was a little bit confused because they had the word reserve in it. So, and when they say reserve, they're not talking about cognac here. But what they're basically implying is that this section has kind of been it's almost been amended out through the whole commenting process as the code was being developed. But essentially, what they're saying is it's now optional. So just because a jurisdiction is going to go and adopt the 2024 IECC, that doesn't necessarily mean that they are stuck with having to adopt this portion of the code. It is optional based on, from jurisdiction to jurisdiction, what they want to do. Okay. So just keep that in mind. You might see that section reference in there. It doesn't necessarily mean that it's being followed. So wait for the code for different jurisdictions to adopt it and see if they actually include it in their code verbiage. But if they do include it, the requirements are basically as follows here. So spaces that fall under the B, E, M, and S occupancies, defined as your office space, your education spaces, retail, storage areas. If those spaces collectively on a project exceed 10,000 square feet, then you have to have demand response controls on that project for those spaces. And to be more specific, for at least 75% of the area of those spaces. So if you had I don't know, 10,000 square feet against 7,500 of those square feet would have to follow the requirements of the demand response, which basically states that whenever you get a signal from anything other than the actual end user, the people occupying the space, you get a demand response signal to the building. Usually that's going to come from your utility company or anyone else out there that would be running some sort of a program for, saving energy or basically taking the load off the grid. Once you get that signal, you have to at least reduce your lighting by no less than 20%. You get about 15 minutes to go from full output to 80%. And I think the reason they're doing that is really so it's not disrupting the tenants using the building, which makes sense. If you have high-end trim settings, so again, that was an exception for manual dimming in a lot of spaces. So if you're using that strategy for a space and there's high-end trim set, you still have to reduce by 20% from whatever that high-end trim setting is set to. And then you have to have the ability, once that signal goes away from the utility company, to return lights back to their previous state. Now, a lot of how this code reads is actually kind of interesting from a controls programming standpoint anyways. The logic required from lighting control system is kind of intricate, if you kind of really think about it, because let's just say that I had a space, an office space, that was dimmed to 50% whenever this signal came in from the utility, right? So what happens with that space, right? Technically, the way the code is intended to work is if you're calculating a building's lighting power, and you say, at 100% it's X amount, and I want to reduce it by 20% when I get that signal. So I'll just say it's 1,000 kilowatts or whatever. And whenever I get the signal, I need it to go down to 800 kilowatts. Well, if a space is dimmed down to 50% already, it's actually using less than the required by the signal. So what does that mean for the control system? Is it saying that whenever I get this signal, now I have to get my lights up to 80%, even though I had them at 50? Or does it somehow need to recognize that it's sitting below 80 and then say, do nothing with that? There's a lot of if-then logic, basically, I guess is what I'm getting at, that would have to be built into your lighting control systems. Um, and again, we're talking about having to fully network those lighting controls as well, because the way that these demand response signals are intended to work is it comes in from one single point to a single location in the building, and then that needs to get transmitted to all the spaces that would have all of these lighting controls in it, right? So that's going to drive network lighting controls for these applications. But again, a lot of systems out there, I don't think are ready quite yet to really process this information. Most systems on the market are designed to do a last signal wins sort of scenario, right? So if someone turned the lights off, if the next signal is the schedule that says sweep the lights off, it's going to follow that schedule. It's going to follow that next signal. So how does that work with this sort of application? Because again, even returning lights back to their previous state, well, the system's going to have to somehow record the previous state. And then, I don't know, maybe it's a duration of 4 hours. Does that mean that no one can adjust any of their lighting in that space for that 4 hour period? And how is the, system keeping track of what's going on? So it's kind of interesting. I'm going to have more conversations with our manufacturers and kind of get their take and seeing, what kind of provisions they're putting in place um, for their systems, and we'll definitely share that information with you guys. So, all right. Some of the exceptions for demand response controls. So the first one's very obvious, right? If you're under 10,000 square feet for these occupancy types, you don't have to do it. This next one I highlighted because this one kind of I wasn't really sure how this was going to get handled, right? But I think this is one of the ones that's going to really drive the decision making for jurisdictions on whether they do or do not adopt this section into their codes. So basically, this states buildings where demand response signal is not available from a controlling entity. So, in my opinion, that's going to be your utility company, or again, anyone other than the owner themselves saying, I want my lights to dim or whatever. So if that's not in place, then you don't have to do it. So I think again, a lot of these jurisdictions are going to say, okay, well, do we have any incentives from our utility companies in order to do this? Does it make sense? And if there's not, or they feel like there aren't gonna be in the very near future, then they might not adopt this into their code. And then you have your other four here, parking garages, ambulatory outpatient clinics, basically medical facilities for the most part don't have to comply with that. And then parking, I'm not really sure why parking garages, why they added that on there. Maybe that's for safety and security purposes. Although, again, reducing your lighting by 20% doesn't have a very huge impact on the overall lighting output. So maybe they're concerned that in maximal lighting calculations, there's going to be some dark corner in the parking garage. And if you reduce it by 20%, that might endanger someone. So my 2 cents there. But so that's demand response. And then noteworthy section here. So Colorado specific. So traditionally, Colorado has not had a statewide adopted energy code, right? Um, Idaho, if we have folks from Idaho here, you guys have the 2018 right now. Montana, you guys are under the 2021 statewide. Colorado, again, has not had a statewide energy code. There was a bill passed a couple of years ago that basically mandated that any jurisdiction in Colorado, if they were to update or somehow modify any of their building codes, didn't have to be lighting specific, or energy code specific, they would have to adopt one of the three latest energy codes, which at that time was the 2015 IECC, 2018, or 2021. So currently, Colorado is working on basically their version of a statewide code. They're calling it the Colorado Model Low Energy and Carbon Code. Um, and that is slated to be published September 1st of 2025. But essentially what they're doing is they're modeling off of the 2024 ICC, and they're putting in their amendments, and they're saying that as of July 1st of 2026, if any jurisdictions in the state are going to make any sort of modifications to their building codes, they have to adopt this Colorado model low energy carbon code. That is a mouthful. So essentially what I'm seeing here is they're trying to get all the jurisdictions to be on the same level. So I think that's kind of one of the first steps to eventually probably going with a statewide adopted code. Now there's an online version of this already as far as what they've got currently. So again, it can change. There are things that can get amended still before September 1st when it's going to be released. But currently what I'm seeing in there is that they are going to do away with plug load controls in this code. So I'm sure a lot of you guys are cheering right now. But however, I do see that they have the demand response portion in the code, and it looks like they are planning on adopting that at least as of today. So for Montana folks, you guys have been under the 2021 IECC for some time, but it sounds like back in September of last year, the admin rules of Montana decided they're going to amend some sections out of that code. So you guys are no longer affected by plug load control requirements as part of 2021 IECC. They also nixed the secondary side lit daylight zone, so you only have to worry about your primary daylight zone at this time. Again, I don't know what happens once 2024 is being looked at and being adopted. I don't know if they're going to change their mind and go back to including some of these items, or they're just going to, exclude them up front. And then they also removed the energy monitoring requirements, which didn't really necessarily impact lighting controls directly, because most of the time, the most efficient way of getting that done was through devices that were upstream of the lighting controls, or EMON, DMON devices that were just metering things at the circuit level rather than like the switch leg level. In theory, you could have used your lighting control systems in order to achieve this, but again, that would have probably required fully networked systems, which we're not going to be anywhere as cost efficient as just using those upstream devices. But just FYI, those were the changes that were kind of recently made. All right, so it sounds like plug load controls, a lot of people are kind of moving away to not wanting to do them, which is totally understandable. Again, for like the Colorado market, for example, our best hope is probably that we have to wait until at least July 1st of 2026 until we might see some of that go away from being required on our design. So while we're dealing with that, and I've beat this horse to death already, but I still keep seeing it. So I want to kind of revisit this topic here. So there are right ways and wrong ways to do plug load controls. And what I've seen, because they do, drive the cost of the projects, control specifically. A lot of times it's the first thing that people try to, VE or find a way to do it more cost efficiently. So here's an example of, a private office application where typically you would have a wall box sensor that's line voltage, dimming capable. Technically, that checks all the boxes in the code required for that space in terms of control your lighting. However, you can't really use this device to control your receptacles because it does not have a separate dry contact output of any sort that can communicate to a plug load power pack. So what I've seen people do is use rib relays, or in this case, a power pack like this, and they'll tie it into the line voltage output of the occupancy sensor, saying, hey, whenever someone comes in here to use this space, they're going to turn on their lights and then they're going to energize the receptacle. So again, the problem with that is technically it's code compliance, because again, the code doesn't state anything about having to control your receptacles separate from your lighting. So the only blurb in there about occupancy sensor control for receptacles is that your sensor has to turn off your lights 20 minutes after you leave the space, which in this application, technically that would happen. If you turn on your lights, you get your lights on, you get your receptacles energized. If that sensor doesn't pick anyone up, it's going to turn off your lights, and therefore your power pack gets de-energized, your receptacles turn off, and technically that meets the code. However, it's not good practice, again, because you're forcing the end user to turn on their lights in order to use those controlled receptacles, which is really not the intent of the code. Again, they just didn't word it very well. I actually have an amendment that I submitted to the 2027 edition. I didn't make it to the 2024, but asking them to kind of add a little blurb in there that clarifies that essentially your lighting load should be separately controlled from your receptacle loads on the aux sensor. So as you guys are designing this, again, this is kind of a loophole that is being used. So I want you to be mindful of that, because again, you could end up with an end user that's stuck having to use their lights in order to use their controlled receptacles. And that doesn't work. That defeats the whole purpose. So if you can, in the meantime, throw in a note if you have plug load controls in your project that basically states that your lighting loads need to be separately controlled, manually controlled, separate from your receptacle loads, which just need to follow the occupancy sensor signal in that space. And there are multiple different ways of getting that done: wired, wireless, digital, analog, definitely, a bunch of different ways. So there are options. Okay, and that is all I had. So I think we're doing pretty good on time. Again, this is kind of going through that functionality. So again, summary, new occupancy sensor requirements, they just simply added a few more spaces, new dimming requirements, brand new to the code. And now there's a lot more spaces that are defined to have manual dimming requirements. New daylight zones, that has been halved as far as the wattage requirement goes to have a daylight zone. And then the demand response controls, we'll see where that rolls and see who ends up adopting it. So that'll be kind of interesting. All right. Do we have any questions? Hopefully I didn't go too fast.
We did get a few questions, Mike. And if anybody has additional questions, feel free to unmute yourselves and just ask them. So the first question is, does decorative lighting count for daylight zone wattage calculation?
Decorative lighting for daylight. Okay, so if you have decorative lighting inside of your daylight zones, again, unless it's a specific application sort of lighting, like, maybe you have a pool table or something that's near a window and you have light fixtures over that, technically I would consider that special application lighting. So in that case, no, you probably won't have to do that. However, if that decorative lighting is being used as part of your general lighting in the space, yes, you do have to take that into consideration. I know that one could be kind of tough because you really don't have as much control as to what ends up getting put into that fixture, right? Because a lot of times those are screw-in bulbs. And on top of that, the dimming usually is not 0 to 10 volts. So then that kind of drives some of the cost on the controls specifically. You have to have phase dimming modules that you have to add. But yes, so that's the way that would work.
Okay. Next question. Do you need 2 photocells for primary and secondary daylight zones?
2 photocells for primary and secondary daylight zones. Yes and no. Let me see if I can go back real fast. So if we're looking at our primary, secondary daylight zone, so if we got this application right here, so for a closed loop photocell, there's closed loop and open loop photocells. For a closed loop photocell, you would need two. So closed loop photocell is monitoring the actual lights at your task level, right? Whether that's going to be the floor in that space or that's a desk. That photocell is actually reading the light level at that task surface. So it's looking directly down underneath the lights being provided underneath each one of these zones. So in this case, you would need two separate photocells. Um, Closed loop photocells work great for low ceiling mount applications. Um, so ceilings that are probably 12 feet or lower, because again, they have to be able to read all the way down to the task level. And the farther away you put them from that, the harder it is for that photocell to pick up those levels. So you would need to, in that case, you can use an open loop photocell. So an open loop photocell only looks at the natural light that's coming into the space. It's going to be mounted really close to the window. And you can calibrate an open loop photocell to run multiple different daylight zones. So in that case, you really only need one daylight sensor. Um, and those are better for high mount applications, again, because you're just mounting as close to the window. So it doesn't care if that window is 30 feet up in the air or if it's 10 feet up in the air, it really doesn't matter. Because again, it's just monitoring the natural light coming in. And so when you go to calibrate that space at your original time of programming, um, you would end up sending that photocell to say, okay, when I'm reading this many foot candles from natural light, I know I'm actually getting this much foot candles at this task level in the primary zone, this much in the secondary zone. So then I adjust my artificial light and tell it, okay, well, when I get this value from natural light, I want primary to be at this value and secondary to be at this value. So the drawback there, though, is again, things can move around in the space, especially if it's an office space. So whatever you did, whatever calculations you did when you initially programmed the system, once you move things around, um, things can change, and that photocell will not automatically recalibrate itself. Whereas with closed loop photocells are going to be again monitoring directly underneath the photocell itself and then seeing what's going on in the space itself. So
Okay.
yes and no.
Okay. Another question. Can you do local timer switches for plug load controls?
Local timer switches. So yeah, so schedule based. I guess by timer switches they probably mean like a schedule, like an switch of some sort that runs a schedule. Um, yes, you could, and there are devices on the market that can do that. However, you're using a timer switch. Usually those can only handle one circuit. So you basically end up getting stuck with using one per circuit that you have to control. So, if you think about that in like a classroom application where, you might have a dozen classrooms, each classroom has upwards of maybe three circuits per classroom that you have to half switch via that timer switch. That could be a lot of clocks to maintain because those are all going to be individual clocks. And there's inevitably going to be some time drift that someone's going to have to go through and adjust. So yes, you can do it, but again, I guess be mindful of the application. If you're just trying to, hit that check mark and it's a very small space, you only have one office and it just has to meet the code. You could do that. I think those devices typically would be like a separate switch from the actual receptacles. Sometimes they have the receptacle built into that switch. But in that case, a lot of times you'll end up losing your unswitched receptacle for that specific um, receptacle that you're putting that device into. So just something to keep in mind.
Okay. A couple more questions. Jenna asked if we could show the skylight zone requirements again.
Yeah. So yeah, there you go. And it's 75 watts.
Okay. And Jenna, if you have any specific questions, let me know. And then a couple more questions. Is theatrical lighting included toward daylighting zones wattage levels?
So no, I would say theatrical lighting again. That's going to be very it's especially lighting basically. So that would not count towards your house lights may have to dim. In most cases, I haven't really seen too many theaters or applications where you have theatrical lighting that would have windows typically. Usually those are kind of enclosed spaces, but I suppose, you'll see them in like gymnasiums sometimes where they kind of use that space for multiple applications. So, but no, those do not have to be daylight harvested.
Okay. And then the last question, unless anybody wants to chime in, can Mike go over IECC requirements in Washington, or have you heard anything on the latest WSEC edition?
I will have to dig into that.
Okay.
Um, yeah, so yeah, it's not a territory that we traditionally cover right now. So I have not dug into that, but I can take a look at that. Yeah, if you send that over to me, I'll dig into it.
All right. And yeah, just shoot that to me and I'll pass it along. So-
Perfect.
oh, regarding the theater questions, if there's a gym specifically that doubles as a fellowship hall,
Yeah, so
I
that's kind
believe.
of what I imagine this might be. Addressing. So again, the actual theatrical lighting itself. So I guess what I'm imagining is there's some projectors or something like that that shine it on the stage or track lights that would light up a stage. So those for sure do not have to be daylight harvested. However, your house lights may need to be daylight harvested. Now, typically, again, they probably would have to have some sort of shades or something in place when they are doing some sort of a theatrical presentation and they're actually using the track lights in that case. So in that case, you're not gonna have to worry about that because you're gonna be you have your shades up and you're really just manually controlling the house lights anyways. But I think that the general lighting in that space technically would still have to be daylight harvested.
All right. Sounds good. Well, that was the last of the questions that I received. So I think we can wrap this up. Thank you so much, Mike. Great information. And thanks everybody for the questions. Um, we will be sending out an email tomorrow, have the video recording, the slide deck, a few follow-up links. And then we are pretty much scheduled through Q1 with Wednesdays with MH. You can find all those on the calendar section of our website. So take a look, sign up for anything that looks interesting. And I think we're done. So we'll see many of you next week. Have a good afternoon. And thanks again, Mike, for putting this presentation together.
Yeah, thank you guys for taking the time and joining.